what we need to look at is scientific notation. I'm going to explain what that is once I've got you to do this little activity first. So can we please represent those numbers as expanded form, because they're currently in index form. Sam, what do you reckon the first one is?
10 times 10.
Very good. Adam?
10 times 10 times 10.
Very good. And random Jaden?
10. We've got 10 times 10. Do that last one.
Okay, very good. I was going to get you to see if you'd say it a couple times, but well played. Now, that is the exact reason why you have scientific notation. Because I don't like saying 10 times 10 times 10 times 10 times 10 times 10 times 10. Gets a bit tedious, correct? Mathematicians and scientists are extremely lazy, so we try and find shortcuts. Before we find out about the shortcut, we need to solve what this means. So what does 10 to the power of 2 equal? 10 times 10, which equals?
100.
Okay, very good. What's 10 times 10 times 10 equal?
1,000.
Now, who knows what 10 times 10 times 10 9 times? Who knows what that is?
100 million.
Off the top of their head. Ready?
1 times 0.
1. So when we stop?
100 million. 2.
Stop.
Stop.
Okay, good. So how do you know? So we're seeing a pattern here, aren't we? The number here represents the amount of zeros. I want to hold off that. Why do you think I want to hold off that? We had a little look at this last lesson. We tended to get these right when it was like this, for example, 10 to the negative 2. We kept getting those a bit wrong. Why? What we're actually doing is moving the decimal place. Okay. So people can get a little bit caught. So that actually means, so what I do with my 10 to the negative 2, does anyone know what that means before we go any further? What does it mean?
Is it 10 divided by 2?
It's not quite. It's 1 divided by 10 to the power of 2. What is that? 1 over? 1 over 100, which we represent as 0.01. What's the trap? Do we need that first 0?
No.
It's a convention, we don't. So how many zeros have I got?
1.
So we have to be careful. What this number actually represents is how far we're moving the decimal place, forwards or backwards. If it's negative, we're moving the decimal place because that started as 1, it was 1.0, and we're moving the decimal place 1, 2 back up. So it's now here, and that's our new value. Cool? So that's the trick with our 10 to the power of whatever. Now, when we're talking about scientific notation, what's something that catches you about that? What's something that stands out about that term, scientific notation? What's something doing? So I'm asking you what catches you out about that term, scientific notation. Sam? Science. Okay, why do you think it says that? Just because?
They use it in science.
They do use it in science. Why?
It helps them with something.
It helps. What does it help with?
They can show measurements of small objects.
Awesome. Great response. They can show measurements of really, really small objects. So like if you think about the number of atoms in your fingernail, for example. How many atoms do you think you've got in your fingernail?
2.
Million.
Millions? Is that it? Just millions?
Hundreds.
More. More. About this many. Okay, about 6 times 10 to the power of 23 atoms in your fingernail. Now you've got a few fingernails in your body, and you've got a few things bigger than your fingernail in your body, correct? So in science, we deal with things that are really, really small. We deal with things that are really, really big. The distance between here and the sun, for example. Who knows how long it takes light to reach us from the sun?
2 days.
Well, it travels at the speed of light. Yeah, around about 8 minutes. I think it's about 14 minutes, but let's just go with 8 minutes because it doesn't actually matter. It's just more for the purpose. So 8 minutes. How many seconds are in 8 minutes? 60 times 8, correct? How fast does light travel?
Pretty fast.
Okay. Big number. Big number, correct? So scientists have to deal with this, and it gets really tricky. It doesn't have to be. Let's just say I was dealing with this, right? I don't want to do it with 60 for now. I just want to make it nice and simple. What is that? I want 300 million times 8. Well, what I can do is just do these two. What's 3 times 8? 24 times 10 to the power of 8. That was real hard, eh? Looks very impressive, but it's quite simple. So what it does is it makes really, really big and really, really small numbers into much more manageable sections. Cool? That's the purpose. Now there are a few conventions. Am I in scientific notation fully there? Why not? It should be 2.4 times 10 to the power of 9. Why is it 9, not 8? I've moved the decimal place back, so I've accounted for it by adding 1 to 1 power. Cool.